So large language models like ChatGPT, they've just completely exploded into our lives, haven't they? It feels like one day they weren't here and the next they're everywhere. And it's brought a ton of excitement, but also, let's be honest, a lot of confusion. We hear people saying these systems can understand or think, but what's really going on under the hood? Well, let's dive in and find out.
This right here is the central question, isn't it? We use these very human words like reason and understand because what comes out of them feels so, well, human. In this explainer, we're going to peel back those layers and see what's actually happening on the inside.
Okay, here's our game plan. We'll start with the black box idea, and then we'll really question what it even means to understand something. Then we get to the fun part, the one simple trick that powers this whole thing. After that, we'll see how they learn, how they respond, and we'll land on this core idea that it's all about prediction, not actual thought.
All right, section 1, the LLM black box. From the outside, it seems pretty straightforward, right? We type something in, and a response comes out. But our goal today is to crack open that box and unravel the mystery of what's happening inside.
You know, our gut instinct tells us it's a simple two-step process. First, the machine has to understand what we're asking. And second, it uses that understanding to generate a reply. It makes perfect sense. But that very first step, that word understands, is exactly where our assumptions start to fall apart. So let's jump right into our second section and really challenge that idea. What does it actually mean for a machine to understand language? Because you'll see it's way more complicated than just knowing the rules of grammar. Look, a machine can easily be programmed to know that the cat sat on the mat is a valid sentence, while the other phrase is basically just word salad. That's just following simple rules. But knowing the rules of grammar is not the same thing as understanding meaning. Not even close. And here's the real kicker. Both of these sentences are grammatically perfect, but the word bank means two totally different things. The real challenge for AI isn't sentence structure, it's getting a handle on context. And this is where LLMs take a really different and kind of surprising approach. So if they don't understand context the way we do, how on earth do they work? Well, this brings us to section 3, and what I like to call the aha moment. See, LLMs don't sit there reasoning about riverbanks versus financial banks. They rely on one incredibly simple core principle. And this is it. This is the single most important thing you need to know about how these models work. Their entire ridiculously complex system is trained to do just one thing, over and over and over again. Predict the next most likely word in a sequence. That's it. That's the trick. Okay, hold on. If its core job is just predicting the next word, how does that lead to these incredible, human-like conversations we're having? Let's move to section 4 and see how this all comes together during the training phase. So, before an LLM can answer a single question for you, it has to go through this super intensive process called training. It's basically fed a huge chunk of the internet, books, articles, websites, you name it, all with one single goal: get insanely good at predicting what word comes next. This training loop is absolutely crucial. The model gets a piece of a sentence. It then calculates the odds for every possible word in its vocabulary that could come next. It checks its best guess against the right answer from the data. And when it's wrong, which at the beginning is almost always, it calculates that error and makes a tiny adjustment to its internal wiring. Now just imagine doing that billions of times. Through that relentless process of predicting, checking, and correcting, the model isn't just memorizing sentences. It's learning something way deeper. As a byproduct of trying to get the next word right, it starts to learn patterns, word associations, grammar, and even the relationship between a question and its answer. It's all about pattern recognition on a massive scale. So now we know how it learns, let's take a look at how a fully trained model actually comes up with a response for us. This is section 5, what's called the inference phase. Inference is just the fancy word for when we're actually using the model. The big difference here is that there's no more learning, no more error correction. The model is just using the patterns it's already learned to do the one thing it knows best: predict. Check out how this works step by step. We give it our prompt. Based on that text, it predicts the most probable next word is the. Then, and this is key, it takes that entire new sentence as its input and predicts the next word, which is capital. It just keeps adding its own prediction to the end and running the whole thing again, one single word at a time, until it generates what it thinks is a complete, probable answer. It's not thinking of the whole response at once. It's building it piece by piece.
And that brings us to our final section, where we put all the pieces together. This is all about prediction, not thought. Let's tackle the big questions that pop up once you really get this core idea.
I mean, this is the one, right? This is the question I hear the most. If it's just a fancy pattern-matching machine, why does it feel like you're actually talking to something that understands you?
The short answer is scale. The intelligence we feel is really an illusion created by the sheer size of its training data. It has learned the patterns from a data set so huge, it includes almost every type of conversation, argument, and story humans have ever written down. So when we ask it a question, it's not thinking about an answer, it's recognizing a pattern it has seen millions of times before and predicting the most statistically likely string of words to complete that pattern.
Okay, that makes sense. But that leads to the next big question. If it's so good at patterns, why does it sometimes just make stuff up? Confidently say things that are completely wrong. We call this hallucinating.
Well, hallucinations are a direct side effect of its core design. Its prime directive is to always predict the next most probable word to create a sentence that sounds right. It is not designed to check facts. It doesn't have an I don't know button. So if it doesn't have the specific information, it will still generate the most plausible sounding answer it can based on the patterns it knows. At its heart, it's a prediction machine, not a truth machine.
And really, if you walk away with just one idea, let it be this one. The true marvel of this technology isn't that we've built a machine that thinks like a human. The real magic is seeing how incredibly far you can get with prediction alone. That just by learning to predict the next word, a machine can copy the patterns of human language so well that it feels to us like real intelligence. And you have to wonder, what does that say about our own language and maybe even our own thinking? It's definitely something to chew on.